We learned that when humid air rises, small droplets form through condensation and form clouds. However, not all clouds will cause precipitation. Small cloud droplets cannot fall to the Earth's surface because friction will slow the movement, and they will evaporate before they reach the ground. Their volume needs to increase by 1,000,000 times. The condensation process is too slow to explain the growth of droplets in clouds that will produce precipitation. Two processes can explain the growth. The growth in warm clouds is called the collision-coalescence process, which is also called the warm rain process. It happens when larger droplets fall through the cloud and collide with smaller, slower droplets. Coalescence refers to the merging of cloud droplets by collision. Small cloud droplets that pass through a cloud in an updraft and later are pulled down by gravity can grow sufficiently to the size of a raindrop. A second process explains the growth of cloud droplets in cool and cold clouds. It's called the Bergeron process, or ice crystal process, or cold rain process. This process explains much of the precipitation that we experience in the mid-latitudes. The basic idea is that in the midsection of the cloud, in the presence of ice crystals, liquid water, and water vapor, ice crystals will grow rapidly at the expense of water droplets.
Inside a cloud, where temperatures are below freezing, ice crystals may be surrounded by supercooled water droplets. When ice crystals and liquid droplets are close together, water vapor molecules will move from the liquid droplets and deposit onto the ice crystals. This situation causes ice crystals to grow in size, while water droplets shrink. When an ice crystal becomes significantly large, it begins to fall. While falling, the ice crystal may grow in size by colliding and sticking to other ice crystals or by colliding with supercooled droplets that freeze on contact.
In the following, I will talk about various forms of precipitation. Rain refers to drops of water that fall from a cloud and have a diameter of at least 0.5 millimeters. Rain originates mainly from nimbostratus or cumulonimbus clouds. It often starts as snow, hail, or graupel, which melts while it is falling through warm air layers. If rain evaporates before it reaches the ground, it is called Virga. We see streaks of precipitation falling from a cloud that extend only part of the way to the Earth's surface. Drops of water that fall from a cloud and have a diameter of less than 0.5 millimeters are called drizzle. Drizzle mainly originates from nimbostratus clouds. It is a phenomenon that often continues for many hours. Precipitation containing the smallest droplets that are able to reach the ground is called mist. The droplets have a diameter of 0.005 to 0.05 millimeters. The drops of mist appear to be floating but sink to the ground nevertheless. Snow is a form of precipitation in form of ice crystals or snowflakes or aggregates of ice crystals. Low temperatures and low moisture content of the air cause the formation of light and fluffy snow, also called powder snow. During snowfall, the temperature of the lower atmosphere is typically below freezing point. Temperatures above -5 degrees Celsius cause icy crystals to join into larger clumps and cause the formation of heavy snow with high moisture content. All snow crystals are six-sided and come in an infinite variety of forms. Sleet refers to small ice particles that form when raindrops freeze while falling through a cold air layer. Sleet requires the presence of an inversion. An above-freezing air layer must overlie a sub-freezing layer near the ground. When small pellets of ice reach the ground, they are roughly the size of the raindrops. Supercooled raindrops that freeze on contact with solid objects are called glaze. Similar to sleet, glaze requires the presence of an inversion layer. Glaze is formed when the sub-freezing lower air layer is not thick enough for raindrops to freeze. It can form a thick coating of ice, which is also called freezing rain. Hail refers to precipitation in form of hard, rounded pellets or irregular lumps of ice. In extreme cases, hail has been found that had a diameter of over 5 inches and weighed more than 1.5 pounds. Ice pellets with a diameter of less than 5 millimeters are called graupel. Hail is produced in large cumulonimbus clouds, when ice pellets grow by collecting supercooled water as they are moved upward and downward. Each trip through the supercooled section of the cloud adds a new layer of ice. Rime is a deposit of ice crystals by freezing of supercooled fog or cloud droplets on objects. It often appears as ice feathers that point towards the wind. Precipitation is measured with a standard rain gauge. The standard rain gauge has an opening of 8 inches diameter at the top. The funnel conducts the rain through the narrow opening into a measuring tube. This method reduces the measuring error through excessive evaporation. The accuracy of the measurements is 0.01 inches. Everything less is called a trace of precipitation. A method that allows for the electronic recording of the rainfall is using the tippet bucket gauge. A funnel feeds a pair of tipping buckets on a rocker which tips and empties once full. One bucket holds 0.01 inches of rain, and an electronic counter counts the number of tips. Today, our measurements rely heavily on weather radar. In such a system, a transmitter sends short pulses of radio waves that penetrate small droplets but are reflected by larger raindrops, ice crystals, or hailstones. The reflected signal, also called echo, is received and displayed on a TV monitor. The strength of the returning signal gives an indication of the amount and regional distribution of precipitation.